Students, I am very much happy to invite to this wonderful Google Meet where we are going to discuss about the discrete mathematics. The particular topic is about solving a fact by mathematical induction. It comes in the second unit of your discrete mathematical syllabus. Second unit, that is under combinatories, and that particular topic we have this particular type of problems we have to solve by mathematical induction method. Okay, so before that, what is mathematical induction method? First, the given fact is true for 1, it is true for 1 and 2 or what, and then we are accepting that fact is true for n is equal to k. We assume that fact, then afterwards we try to prove that that fact is true for k plus 1 also. Okay, so the first step is we are proving for n is equal to 1 the fact is true. Then afterwards we assume that the fact is true for any k for n is greater than or equal to 1. By assuming that, if we are able to prove that for the fact is true for k plus 1 also, then the fact is proved, because for n is equal to 1 it is proved, for n is equal to k plus 1 it is proved, therefore for any k greater than or equal to 1 it is proved. This type of proving method we call it as mathematical induction method. Okay, now I will take one problem first and then we will prove that. So you must try to prove all other problems by the same methodology, by same techniques. You have to try to prove that. Okay, now let me take that problem. Now one problem I'm going to take now is this one. Okay, so prove by mathematical induction method, or mathematical induction method I must say. What we have to prove is that n cube plus 2n is divisible by 3 for all n greater than or equal to 1. For all natural numbers we can say greater than or equal to 1. This is what the problem given to us. Okay, so it is what a mathematical fact, and this mathematical fact we have to prove by what is called mathematical induction method. Mathematical induction method we have to prove that. Okay, right, now look at that, how I am proving this. The first step here is that step 1, for n is equal to 1, the given fact, that is n cube plus 2n is divisible by 3. N cube plus 2n is divisible by 3. The fact is true for n is equal to 1. That's what we have to prove here. Okay, right, now now I am taking s of n is equals 1 plus 2. So given fact is n cube plus 2n, therefore 1 plus 2n, that will equal to 3. Now for n is equal to 2, what I see, s of n, for n is equal to 2 you substitute, what you will get is that that is n cube, that is 2 cube is 8, plus 2n, 2 into 2 is equal to 4, which implies 12. So what I understand is that for n is equal to 1, the fact is true, that is n cube plus 2n is divisible by 3. Similarly for n is equal to 2, also the fact is true. Okay, so that's what the first step that I have proved. if you suppose that Sn of is equal to n cube plus 2n, then we have proved for those things. Now what I assume is that for n is equal to 1 and 2, the fact 1 is true. Okay, the fact 1, the equation number 1 is true. What is the equation number 1? Is S of n equals n cube plus 2n. Sn of equals n cube plus 2n is true for n is equal to 1 and n is equal to 2. Okay, now what is my aim is that I have to prove that k plus 1 also this is true. That's what I have to prove now. Okay, now look at that. Now let us have the minimizing so that you can see the whole thing coming through there. Okay, now what we see there is that for step 2 what we have to assume that the fact is true for n is equal to k also. Okay, for n is equal to k, the fact 1 is true. That's what I am assuming. If I assume like that, what I will get is that S of k equals k cube plus 2k. K cube plus 2k. Now for n is equal to k plus 1, that's what we have to prove. So I am taking the place of k, you substitute k plus 1, you will get k plus 1 equals k plus 1 cube plus 2 into k plus 1. That's what we have here. Okay, now I'm going to simplify the right hand side. Okay, the right hand side, that is what I am going to simplify the right hand side of that. Okay, so look that this cube I can expand. If you expand the cube terms, what you will get is that k cube will get plus 3 into k square plus 3 into k plus 2 into k plus 1 plus 1 with k plus 1. That's what you will get. Still you simplify, you will get k square plus 2k plus 3 into k square plus k plus 1. So this is what the right hand side we will get. Okay, now this is what we have the right hand side, and if you put any value here, definitely this will be divisible by 3. Okay, for any value of k, we will see that this is divisible by 3. Okay, therefore the right hand side is divisible by 3. So this way of solving the problem by step 1, for n is equal to 1, the given fact is satisfied. Given fact is this S of n equals n cube plus 2n is divisible by 3. This is a fact. For n is equal to 1, we have to prove that. For n is equal to 2, we have proved that. Okay, right. Now we are assuming that for n is equal to k, the equation number 1 is satisfied. Equation number 1 is satisfied. This equation number 1 is satisfied. From that we are substituting k is equal to k plus 1. Then at last right hand side gives you some idea about the whole right hand side expression is divisible by 3. Therefore for 1 it is true, for 2 it is true, then for k plus 1, for all n greater than or equal to 1, the fact is proved. And this way of proving a given fact is called by mathematical induction method. So in this class I have taken one problems where the fact is solved by mathematical induction methods. Okay, so all the best. In another Google meeting I will take another problems and solve it. Okay, so thank you very much for being with me for the past some 15 minutes or 10 minutes, I think so, because the software is allowed only for 10 minutes. More than that I cannot go. So in the next class I will take another problem and come with you. Thank you very much. Thank you. Okay, welcome students. In today's teaching, I am going to take one problem, and that will help you to understand more on discrete mathematics. Okay, now I am going to recap or give feedback about this discrete mathematics. In discrete mathematics, we know already that there are 5 units. The first unit is about the logic and different types of proofs methods are there. And then in the second unit we talked about the combinatories, that comes about countable principle, and then inclusion exclusion principle, and then recursion problem, how to solve the recursion problem. All those things are coming in the second unit. Coming to the third unit, we talked about the graph theory, different types of graphs. Okay, then bipartite graph, regular graph, complete graph, and then Hamiltonian graph, and Eulerian graph, and then some theorems involved between the vertex and edges, and that all those are coming in the third unit under the topic graph theory. The fourth one is about the algebraic structure. Algebraic structure. So start with what is a monoid, and then semigroup. Uh, then it goes like a group. Then what is a ring, and what is a field. So all those things and those connection called theorems also coming in that particular unit number 4. In the last unit, we talked about lattice and Boolean algebra. In that lattice and Boolean algebra, we talked about how to draw the hash diagram for the given uh, lattice, and also Boolean algebra is advanced form of a lattice. Okay, complemented distributive lattice is called Boolean algebra. So all these things we have to study in the discrete mathematics syllabus. Okay, so those are the things, a very short form, that is what I have to talk about. Now let me discuss in detail about what those things are. So in the first unit about logic and proofs, in that statements formula will be given,